recording.
Cool. All right. So what's the audio? Is it this one or this one?
It's
Both.
both.
All right. We are going to begin. This is a talk about HyperDrupal. I hope to explain that sufficiently. You can let me know at the end if I have or have not. I first wrote a blog post about this last year. I don't know if anybody has seen it come through the planet. But I'll basically be talking about how we can mature our implementation of and consumption of REST APIs using Drupal. So of course, first there's the little introduction. I am Ryan Zarama from Commerce Guys. I'm in charge of our community development and sort of internal R&D team that we use to develop the Drupal Commerce core module, other modules, and distributions and all that stuff. So for my day job, I basically get to write Drupal code and talk to Drupal people and help people learn how to use Drupal. And I almost never have to actually do paid work, and I like it that I don't have to. So it's a fun spot. Commerce Guys has been a fun place to work and grow for me. And this whole presentation is kind of an outworking of some of the work that I've done to support our developer teams on projects that they've done. So I'll talk about that as the presentation goes on. Of course, the question I have to sort of answer right off the bat is why am I not just talking about Drupal Commerce? Usually when I go to Drupal camps and conferences, I give the overview of Drupal Commerce and the distros and our roadmap and all that kind of stuff. But honestly, I feel like I've been saying the same stuff since Chicago or earlier, and it's just been getting kind of old for me. And I know that not everybody here has been to every single one of my presentations, but I hope to sort of talk around Drupal Commerce about the things that we use to facilitate commerce through Drupal, and so still talk about the project, but also talk about something that's more generally applicable to the Drupal community. So I also have the question, why talk about REST and hypermedia, which that word is actually, it was very threatening to me when I first learned about it because I just had no clue what it was talking about. But does anybody remember HyperCard? Okay, did you make games and presentations and all that stuff in HyperCard? This is like an old Apple thing. It's basically like PowerPoint, but you can actually put image links into your slides. And so the word hyper there as well is there as well, much like it's in the word hyperlink. And of course, well, I guess that's all I can think of off the top of my head. But the idea is that hypermedia is just some sort of data that tells you how to get to other data. Some sort of presentation of something that links to other documents or images or embeds other things like a CSS file that imports CSS from elsewhere. So that's all that hypermedia is. And of course, REST is what we talk about when we build web APIs, web services. And we'll sort of get through what that actually means. But the reason I got into it in the first place and why I'm talking about it now is because we had a need to build REST APIs for some of our clients. So like a large-scale Drupal Commerce deployment that has a commerce server and then multiple client sites that are all managing their transactions through the server. We had to build a REST API. And I didn't actually know what that was. I didn't know how to build one. I just knew the services module existed. I didn't really know how it solved this challenge, so I just sort of dove in head first, and I became what's known as a Restafarian. I'm not maybe a rabid Restafarian, but I do appreciate where people are thinking and heading in this direction. So there may be some other reasons too for me to give this kind of a talk instead of my normal commerce talk, and part of that is that I'm a little bit attracted to constrained systems. So this is QBasic. Did anybody do QBasic or QuickBasic development? Okay, this is how I learned to program. I actually went to Bible school, and I was not learning computer science or programming there, but I did have a hobby, which was to write QBasic games. And there was a very active development community up until the early 2000s that was basically pushing the boundaries of what you could do with QBasic and QuickBasic, and then later our own derivative of it called FreeBasic that actually just takes the basic syntax and makes a modern programming language out of it. So that was my background, and I was attracted to it because you're not just making something fun, but you're doing something fun with a very limited system. It's sort of you have to work within the constraints that you're given, and you kind of have to be creative how you solve challenges like memory management for loading all of your images or large level maps or whatever else it is that you were doing with QuickBasic. So I'm attracted to constrained systems. I'd still develop for the NES if I could. So actually people do still develop and sell NES games, but that's another story. I'm also attracted to niche development communities. Does anybody here play roguelikes? Or do you remember the game Rogue, or maybe Atom, or NetHack, or Angman, or yada yada? Okay. Probably more people are familiar with Diablo, which was a computer game that basically was this sort of like randomly generated dungeon crawler. Of course, it was real time, true roguelikes. If you want to be a roguelike-afarian, they were ASCII games that have turn-based movement, are very strategic. They involve resource management, discovery, randomization, permanent death, etc., etc., etc. But again, in a niche development community where you're working with these constraints to build something fun and new, you have to be creative and you have to be passionate about it. Otherwise, you just switch to doing something else. If you don't really have a passion for making and playing roguelikes, you probably would graduate to more modern console games or PC games. But I'm kind of there. But those aren't the only reasons why I'm attracted to REST. It's also because I consider the promise of REST, and what I'll be talking about is the API equivalent of a wiki walk. Are we familiar with that term? Yeah, getting lost in Wikipedia, you just click link after link after link after link, or TV tropes, you just click link after link after link. And the idea is that our APIs could sort of facilitate that level of navigation between data sources, not just documents and information and whatnot. And again, I'll tease this out as we go, but I really believe in the promise of REST at this level, where your API server actually prompts you where to go next if you're trying to use or consume or browse the API. And maybe it sends you out to an entirely different API, but because you have the same set of constraints in these two different APIs, you can just move from one to the other without having to reprogram the client to understand data from this server versus this server. So I want to see that happen, and I want Drupal to be a big part of making this happen, much like Drupal was a big part of the Go PHP 5 movement, and OpenID, and somebody help me. I'm missing something else that we RDF. Our RDF on any Drupal website. Much like we've pushed forward these technologies and these concepts, I'd love for Drupal to do that with REST, and with Drupal 8 we actually have a really good opportunity to be a part of that. So let's actually talk about the wiki walk. So to go back to that analogy, the World Wide Web facilitates this sort of like mindless linking and clicking and navigation through this huge library of information. And it does it because we've come to depend on three technologies. So there are three basic technologies, and if you're curious, I do have a link here to a presentation that fleshes this out more fully. But three basic technologies have created the web that we know and use. And the first is the URI, or when you're browsing websites, it's the URL, but just sort of the idea that everything on this distributed network has an address. And all of our clients know how to resolve a URL to a particular computer somewhere and then get a document from it. So I can type in buywombats.com and suddenly get attached to my Rackspace Cloud server and start downloading, documents or quick basic games from that website. So I mean that's pretty simple to understand. I think everybody here probably knows what a URI is. So moving on, there's also HTTP, and this is the protocol, the communication protocol that lets us fetch data from servers and send data to servers. And that involves different things, like specifying host names and paths and sending query strings and did I already say post data? So sending some sort of data in some sort of recognizable format to a server to know how to respond to whatever it is that you're sending them. So HTTP is just sort of the protocol that facilitates all of our communication around the internet. And mostly whenever you're clicking on links and navigating from website to website, you're just using what are called GET requests, which say, hey, fetch me this data from this URL. And then the server will send a response, typically going to be in HTML. And HTML, of course, is the technology that our browser uses to render this data into something that we know how to use, how we can click on stuff, we can fill out forms, we can see images that get embedded in here and whatever else. So, I don't think I actually meant to explain all of those already, but we'll just flip through these slides really quickly. So the URI, of course, is straightforward. The HTTP request, we've already talked about this, but there are just some really one key thing as far as REST servers go is the idea that when you send an HTTP request, you can actually specify what type of data you want to get back from the server. So that'll come back up later. But then the server will respond in kind, sending you some sort of information back. And in the case of HTML, you have links that actually let you browse to other websites, or, as I mentioned before, forms that would let you submit data to the server, or perhaps build a special type of link. So it would be like a form that has a get method. So HTML has all of these things built into it so that we can then navigate through websites. So I can start at the QBasic page. I can click on the structured programming link and get lost somewhere in the wiki, go from there to programming paradigms, and then maybe from here I can go to an external link and I can go actually read an article, oh it's purple, about the 4 main programming paradigms that Wikipedia is referencing. I mean, because Wikipedia's web server and this guy's web server use the same protocols and the same technologies, I'm able to do this, and I don't have to, say, reprogram or recompile my web browser to know how to read this guy's HTML. He didn't use custom HTML tags or some unique subset of addition to HTTP that makes it difficult for my browser to know how to fetch his data. It just works because the whole web is programmed this way. And so the idea here is that because all of these different websites and web servers use the same technologies in the same way, we've been able to sort of virtualize this library of information and facilitate the free flow and free linking of a client anywhere else in this network. So all throughout the World Wide Web, we can browse and access this data that anyone is able to publish so long as they sort of follow the same basic rules. And you might, the word for that, if you're curious, is the idea that we have a uniform interface for accessing data over the internet. So every web server accepts the same type of HTTP requests, knows how to send back responses based on the header information and all that stuff. So the World Wide Web, of course, it's bigger than just information. It's bigger than just encyclopedias and blog posts and news articles and the like. It's become the same set of technologies that we use to virtualize the office, for example. So instead of just taking all of our library data and putting it online and then making the data from all the libraries all over the world available, we can do the same thing for our business software. So within Commerce Guys, like, we don't have to have all of this, all of our data and all of our applications on one computer sitting in our office with an accountant handy and a sales team in-house handy to manage all this stuff. We can actually use those same URIs and HTTP and in hypermedia or JSON or XML or whatever to communicate between all these different web services to build our sort of custom ERP system. So we've taken all of the tools that would normally be present in an office and virtualized them, and now we can link them all together using the APIs that each of these different services provide. Data.gov is doing the same thing for government and government data. It's going to facilitate the free flow of information between here and any other department or mashup or any business that wants to take advantage of this information. And with Drupal Commerce, we're doing the same thing for the storefront. So the idea, of course, is that we can use the same technologies that power the web to get information from our commerce server into a web browser window where someone can buy stuff, or perhaps into their pocket in a mobile app. Or maybe we have a point of sale system that has an iPad at a cash register that ties into our commerce server. And we can also then get that data from inside of Drupal into wherever else it needs to go using the same protocols, the same paradigm, I guess. So whether that's sending conversion data to an analytics service or contacts out to your CRM, or maybe it's like my commerce server example, where we have a REST API to facilitate sending data from one website to another, so it can all be managed in one centralized location. This is why we build web services, and why Drupal 8 specifically has a REST module in core and is trying to make this sort of interaction and free flow of information the norm for Drupal websites. So let's talk about how we can actually use these different technologies, the URI, HTTP, and hypermedia or HTML, to build web services, or what I'll call HTTP-based APIs. And there's, of course, another link here to the chart that sort of maps this all out. And these slides are online, so you don't have to try to write down the links if you don't want to. Because I think that most of us are probably familiar with multiple types of web services. Does anybody want to take a shot? Like, what are some web services or some types of web services you've integrated with or used?
SOAP.
You've used SOAP? Okay. Anything else?
XML RPC.
Yes. That's no longer in Drupal, is it? We had like a Was it just like an include file or something, or a script for that? And then, of course, there's REST. I know, even if you won't speak up. I was in your presentation. So there are REST APIs. And then also just a variety of other idiosyncratic ways to use these same technologies to build web services. So we're going to sort of start from the ground up and say, what would it look like to build a web service that didn't take advantage of any of the technologies of the web? And the basic example for that is actually XML, RPC, and SOAP. Because these web services are using HTTP, yes, but they use it purely as a transport mechanism. They're just using that to get data from one place to another. And honestly, you could package this same SOAP request up into an XML file and FTP it over to the server to process it, and the server's going to process it the same way. You could print this out and then mail it to the office and have somebody type it in, and it would still be processed the exact same way, just not as fast. And so the question, of course, is why do better than this? And I guess maybe I should back up. These types of web services are basically where you take a server and you expose across the web what are called remote procedure calls. That's what RPC stands for. So the idea is the server has some class and it has methods on it or functions, what have you, that you want other people to be able to interact with. And so there's this whole standard language developed for accessing some remote object and executing a procedure on it and passing in parameters and all that stuff. But basically all of the information is built into the actual text of the request, and the fact that it is using the internet to transmit this information is really just secondary. It's not really the concern of the standard. So the question I have to answer is, why even try to do more? And I'm going to just play this video while I talk. Does anybody know who this guy is? His name is Jerry. Well, it takes a minute to get started. My apologies. Jerry is the first ever Pixar short that was screened. So I think he came out with A Bug's Life, and he was Pixar's opportunity to show the world that they could use computer-generated graphics to actually model humans and make them convincing and have some fun with them. So this whole story revolves around him setting up and playing a game of chess in the park. And there's nothing, nothing very extraordinary about that. Many people do this. I actually read about the world #1 backgammon player. Started playing chess in New York City, and then moving on from there. But as you might have just seen, Jerry's park is not so crowded as parks in New York City might be. He does not have anyone to play with. So instead, he just ends up sitting down and playing a game of chess all by his lonesome and getting more and more into it as he sticks it to the guy that he's playing against. What this makes me think of is the idea that this is what it would look like to have all of your applications stack in-house on one machine. You could actually have somebody there that you can communicate with and interact with, where everybody sort of knows how the business operates and just does it. Trades information, or maybe even just manages everything themselves. But if he wanted to play with somebody remotely, he could pick up the phone and say, "Hey, I moved my King's Pawn 2 to King's Pawn 4," and then his buddy could make the move on his board at home, and then they could just sort of play this whole game of chess remotely. They could do play by mail, which was actually really popular. I think it's been done for centuries. People have played chess remotely via mail, via email, and then now, of course, via the internet. We have servers where you can go and play chess online and get ranked and find people that are in your skill level and so on and so forth. So the idea is, if he wants to play chess remotely, he's going to have to find someone that understands the rules of chess, so that if he tells them, "Hey, I'm moving my King's Pawn 2 to King's Pawn 5, the person on the other end can say, "Wait a minute, pawns can only move 2 spaces from the starting position. They can't move 3. So this person that he's playing with has to understand the rules of the game. Additionally, they have to devise some language for playing chess remotely. So that might look like this. Oh, maybe it won't. One sec. That might look like this, where they actually devise a document format where they can encode their chess moves and then send them back and forth. And then each of them not just have to know how to play chess, they have to know how to interpret this document. So now the 2 parties to this chess game, they don't have to be in the same place anymore, but both of them still have to fully understand both the game and how to talk about the game remotely, and nobody in between is going to know anything about this. So if, for example, they were sending all of their communication through some third-party body that was tracking all of the remote chess games in the world, well, that server would also have to be programmed to fully understand this document format. And then if anybody else wanted to play chess remotely and have it tracked by this third-party service, well, then they would also have to. So the idea is that it creates what's called a really tight coupling between the parties involved. Everyone has to understand the rules of the application. Everyone has to understand the data formats and the ways that you talk about the application. But what if you could do it sort of more abstract and more transparent instead of something so opaque as this, which I don't even understand. So we're moving on from XML, RPC, and SOAP to what this chart that I've linked calls RPC URI tunneling. So this is the idea that we're not going to use sort of tightly coupled messages necessarily sent to like one API endpoint that endpoint knows how to decode that message and that's it. We might actually diversify a little bit and define resources or define URLs that have special meaning. So if I do a post to API/user/1/delete, then I might delete user1. Or maybe I go to update, or I can do a get to that URL to get some sort of a representation of that user, whether it's in XML or JSON or maybe just plain HTML. So these are still idiosyncratic because you then end up having to document all of your endpoints. You've included in the URL instructions about how someone's going to use your API remotely. So it's kind of like you've moved your special instructions from the message body, which is what you have in SOAP, to the URL, but it's still special instructions. It requires special knowledge between your server and between all of the different clients, so they become they're still tightly coupled. I can't write a client for your idiosyncratic API that uses these special URLs and then reuse that client for somebody else's API, because then I have to reprogram it to use their endpoints. So the solution to that, to not have to have these sort of idiosyncratic, tightly coupled clients and servers, is to use HTTP. So we go here to our HTTP-based APIs that are using HTTP methods as verbs to interact with the data that you find at specific URLs. And I don't know how visible that is, but you can actually see some examples there in the coding blog. That I can send a GET request, which is one of the HTTP methods, to retrieve some representation of a user, whether that's in JSON, XML again. Or I can use the PUT method to do a full update of that resource, or I can do the delete method to delete it, or the post method to create a new one. So these are typically your CRUD operations where you can create, read, update, and delete your resources remotely. So now I can begin to develop a client that can generically create, read, update, and delete things on anybody's web server that uses this same paradigm. So whether it's my e-commerce server or whether it's data.gov's, I don't know, somebody's random crime map, I don't actually know what they have. So whether it's somebody's crime statistics or somebody else's stock information, whatever it is, if they conform to this interface here of get, post, delete, and put, and they kind of obey the rules, there are special rules for each of these. If they do that, then I can have one client that knows how to work with any of them. So we begin to have reusable code at the client side. So that means I could have a mobile app that points at any Drupal website that uses the same standard and interact with the content or products or other data on that website. Even better, what would be called the Type 2 HTTP-based API would be to use a content type or a media type that's self-descriptive. So instead of just using generic JSON, I can use a media type that actually is documented to describe my data specifically. So if I'm this is maybe a bit heady, it is abstract. I can't really make it less abstract. But the idea is, if I have a collection of nodes, well then maybe when I return you information about this collection of nodes, the message body can actually have information about traversing the collection. So it can say, these are the actual items in my collection, this is the ID, this is the title, and then maybe even begin to link to other parts of the collection, the next page if you're doing pagination, or whatever. But really then you're sort of getting into the territory of REST, which is the idea that my API response from my server sort of includes the controls that you need to navigate my API or to even manipulate data in my server. So this is a simple example from a media type, and I don't know if that's an unknown word, but whenever you request data from a server, you can specify what media type you want it in, whether that's application JSON, text HTML, application XML, or in this case, it's I think it's like, I don't know the full name. It's vnd.amundsen/maze plus XML. But the idea is that there's this media type that was developed for describing mazes. So like just a simple grid-based maze, and the media type documents how to find a maze and start traversing through it, and then recognize the exit once you find the exit. So you can actually create a bot if you had these mazes somewhere that could navigate through the mazes, or you could create a browser-based client that actually visualizes the maze and lets people play them. And so that's what Mike has done, and his book is one of my source books for a lot of my learning in REST API and hypermedia API design. But you can see here, if you can read that my maze XML includes a collection of mazes. So if I just hit the sort of root URL for this maze game, I would see a collection of mazes, and then I could follow a link in each item of this collection to actually start playing a maze. And so the URL here would actually take me to the entrance point for a maze. And then if I did a get on that URL, I could then start traversing from room to room, because the actual response from the server is telling me where else I can go in the maze. Or if I just want to go back to the beginning of the application, it can take me back there. But the whole idea is that my API response is sort of telling you what else you can do within my API. Or if you sort of got a representation of a user, maybe it tells you how to find content published by that user. Or maybe it gives you a little form that tells you how to update the user. So you can actually embed in your API response form HTML if you're just using HTML for your API. That would let me manipulate that data or whatever else. So happy to talk about that more, but we'll move on. Another way to look at this, I sort of went from the ground up that time. Another way to visualize that is to say you have this sort of increasing engagement of the principles of REST. So you start out with what's called the swamp of POX by the guy that coined this model, and that's just plain old XML. So it's just this sort of dumb data that's transmitted from one place to another, and then both the client and the server know how to interpret that, to do stuff on this remote data. Then you get into identifying resources, so that all of my different things have their own URLs and I can access them. And then if I apply HTTP verbs, then I can begin to create these rich clients that know how to read and update and delete and create new things. And then finally, you get to the glory of REST when you embed in your API response the links and forms and templates and whatnot that tell people how to browse the API, just as if they were browsing a website. So I feel like I should give a very concrete example here. And that, I guess the concrete example I would use would be the Commerce mobile app, and I think I had this later in the slides. But the idea is that we have a mobile application that, if I can open it up and you can see it, I promise it's there. Feel free to come put your hands on it later. But the idea is that it's connecting to an instance of Commerce Kickstart 2. And if I had a full REST API here, I could just point my client on the phone at the root of this API, and then from the root there, I would actually put links in it to say, if you want to find a collection of products, follow this link. If you want to find the recent blog posts or deals or whatever else, I could sort of clue in the client, my mobile app, that all these different things are possible to do in my API. And then if the client knows how to traverse those things, it can start to find the information that it wants using the URLs and forms and all that stuff that are built into the API. So then I could click on one of my product pages, and it could get a full representation of that product page and then render it. And then maybe whenever I load a product page, it includes a form in the API response that my client will know how to interpret to add that product to the shopping cart. So then the client maps this add to cart button to that particular bit, that particular form, so that whenever it's done, it can send out a post request to the server, create that new line item, and then maybe advance me to the shopping cart page within the app, where it then gets a whole list of all the products in my cart, and again finds a link to move on to the checkout page, and so on and so forth. And so the idea here is that when you're building a REST API and designing a REST API, you don't just have to think about, well, what are my API endpoints? How do I document them and tell people how to use them? You can just think about, well, how do people actually use my API as if it were a website that they were browsing around? And you sort of approach it from that sort of client-centered mindset that people want to know, how do I get from one place to the next? How do I get back to the beginning if I need to go back a step? How can I manipulate the data? And then just sort of use HTTP as the way to do all this stuff. And that's where I want to be heading. And not only that, I want to be able to communicate it clearer. Because I'm just sort of doing a mind dump now that maybe doesn't really communicate why we should even care about this beyond just documenting API endpoints and going to town. So that's still like a challenge for myself and others like me that want to push this forward within Drupal. Yeah, so we'll just move on from there and talk about what it actually means to get to HyperDrupal, where Drupal is used to build these hypermedia APIs and that can talk to each other and with rich clients and rich servers. We'll talk about first where Drupal is now. On Drupal 7 and earlier, people use the services module, or there are other modules, the RESTful Web Services module, and I'm sure there are others that I don't know about. But the idea is that these sort of combine what I identified as RPC URI tunneling and HTTP-based Type 1 APIs. And so what I mean by that is that there are API endpoints, a sort of traditional endpoint that isn't really a resource. It's not really stateless, which is a REST constraint. And so I can just send a post to a URL to log into the Drupal website remotely and then store a session key locally and send this session information with all of my follow-on API requests to get maybe privileged access to data or different representations of the same data based on the user account and all that stuff. So that's not really RESTful, but we do use the HTTP verbs. So if you are using the services module and you define an update resource, it's actually going to only accept, or it actually lets you send data to the same URL using the put HTTP method to update a node or update a user object or something. And so this is where we are, and this is how our Commerce Server project was developed, and it works great. And that's kind of one of the challenges of really moving forward in REST is that this is pretty sufficient for, just about everybody. Otherwise, I think more people would be pursuing hypermedia and building hypermedia APIs. This works on a one-off basis. If you need to build a Drupal website that has an API, or if you're integrating somebody else's API, you can learn this and do this. And we do the same thing over and over and over because these are idiosyncratic. You can't really develop something in this way and create a generic client because even if you're using the Drupal resources, not every site uses the same resources, or we all have our different ways of doing authentication or access control or whatever else. So this is how we do things now. I'd like to see us progress from there toward what I call HyperDrupal, and Drupal 8 actually really brings a lot to the table in that regard, because it actually ships with a REST module that first of all is defining unique URIs for all of your entity types. So it'll be easy to first expose all of your resources at unique URIs, and then also request representations in different formats because of our use of Symfony 2. We actually are operating more on the header information sent in requests, and that's going to let us send different types of responses. So you can actually request the same data from your Drupal 8 website in XML or in JSON or in YAML or CSV or whatever else it is that you want to get your data in. Drupal 8 will support that in core. It also supports manipulating your entities via that HTTP interface, so using get, post, put, delete. And I think we may actually be using patch as well. Someone could fact check me. But if we don't need to go there. And And then also, did it come up? No, it didn't. Using self-descriptive messages using a new media type called HAL. So HAL is the I can't remember if it's hypertext application language or hypermedia application language, but the idea is that it's a media type that's sort of a rich media type. I guess it can be used with either JSON or XML, but it lets you describe resources and then link to other resources, embed resources. So you picture like a Drupal commerce order, references line items and customer profiles. Well, maybe I don't need to expose all of my different entities to the client, and I just want to embed the line item data into my order. I can do that with HAL, and clients will be able to know how to interpret this data as an embedded resource. Drupal 8 is really pushing things forward. It's not going full on a hypermedia yet, but I think that's okay. I think that in a sense, building RESTful web services and talking about REST is a bit like becoming an actor. And I'm borrowing this from Paul Graham, who sort of said this about startups. But the idea is that you don't just become an actor overnight. You move to Hollywood and work a day job, and then act a couple nights a week, take part in some improv and whatever else, until you finally get your break and you're there. You're on the stage and you're or you're in the movies or whatever. You've become an actor, but all along you were an actor. It was just your level of engagement was steadily increasing, and I see that's happening with Drupal and REST. Is that we can still talk about what we're doing as RESTful web services because we're sort of moving up that maturity model. We're moving up the steps. We went from having XML RPC in core to now having basically like 3 out of the 4 or 4 out of the 5 different principles or concerns of REST in core Drupal 8. And all that really remains is for us to begin to create the links and forms and templates and whatnot in our API responses that let people navigate the API of your Drupal website much like they would navigate the actual front end of your website using their web browser. So really where we have to go from here is both educate ourselves and the community and code. So we need to create better tools. So we need to communicate the constraints and the promise of REST. The idea that if everybody sort of consistently implements these technologies and these concerns, we can have more generic and more powerful tools that are optimized for the constraints of REST. So one clear example are caches, whether they're server-side or client-side caching. Whenever you submit an HTTP request, the server can actually tell you how long it's safe for your web browser to hold on to that that data. And then next time you go to that website, that address, it just serves that data up from the local cache, so you don't have this network traffic. Maybe I don't have a local version of the website in my browser, but whenever I hit that URL at that domain, we use Drupal page caching or Varnish or some other sort of server-side cache to prevent the server from having to regenerate all of that HTML. So it makes it faster. We're speeding up things. Because if everybody uses HTTP properly, we can actually do this sort of caching. There are other advantages if you obey these constraints with respect to writing data as well. So for example, when you do a put or a delete request to update or delete information from the server, it's supposed to be idempotent, meaning every time that request is sent, the same response should be returned. So there are no side effects. If you delete node 1, then I should be able to do that same API request over and over and over without any sort of side effect happening. That would make future versions of that request illegitimate or impossible. And so why that matters is maybe you're trying to update node 2 on the website. And so you send a put request, but you don't actually get a response. And so you don't know, well, did the server ever get my request? Or did I just not get the server's response? Well, I'm not really sure what happened, so I will send the request again. But if there was some sort of side effect at the server, well, then maybe I just created 2 new versions of this because it wasn't idempotent or whatever. So I don't know if that was a great example. I'll have to come up with a better one for next time. But the idea is that these constraints, we can begin to optimize the way that we deal with data remotely around these constraints. And we can also start to enrich our responses from Drupal with hypermedia so that people can start to navigate our APIs. We can also document REST client and server best practices, and I know that the presentation yesterday alluded to this this ebook. This is a link to the Apogee Web API Design Best Practices Guide. That's also linked to from the Commerce Services Project, if you're curious, where they basically say, like, if you're going to implement a RESTful web service, here are some things to do to make it easy for developers to consume your web service. And they deal with consistency and dependency and using the HTTP protocol properly, and creating, I guess, simple ways to query collections of data, or whatever else. It's really great stuff. And actually, the slides from yesterday's API design session have some examples from the ebook if you don't want to read the whole ebook. And then finally, we need to improve our tooling. So we need libraries within, or modules within Drupal that make it easier to consume data from web services, and we need modules within Drupal that make it easier to publish our web services to whoever. And so the goal here is for Drupal 8 and beyond to become the go-to framework for building new web applications. So people don't have to go to Ruby to quickly scaffold out a REST server. They can just get Drupal and quickly scaffold out a REST server, and maybe even one that kicks the pants off of what you get from Ruby out of the box, because we actually have full hypermedia API support out of the box. And then you can begin to have these Drupal sites that know how to talk to one another, and clients that can talk to different websites that any one of us have developed, but they all sort of conform to the same patterns and principles and whatnot. That was the example from earlier. I'm going to stop talking now, though, and just take questions. Are there any questions about why or what or particulars or?
Commerce Guys has an ERP system.
We do, yeah. It's not our own, and it's not actually a system. The Commerce Guys ERP is just how we have used all of these different web services to construct our ideal ERP for running our business. It's not something we implement for other people, but whenever we virtualized our office, we needed the best tool to manage booking and resource management, or resource scheduling and accounting and so on. So that's all that slide was really communicating. Anything else? Oh, yeah.
How long before Drupal becomes sentient?
Before Drupal is how long before Drupal becomes sentient? I guess that's a Drupal 9 or 10 thing. But that, I would love for that to happen. I would love to see computers that know how to browse our APIs and do stuff with it, just on their own. Like, there's an example. There's a program that is creating through trial and error browser-based games, and so it learns how to create a game and then how to make it playable, how to make it winnable, and it's just iterating over this. Like, it's done hundreds and thousands of iterations by now. You can actually go play each of the different iterations it's come up with and decide if it's fun or not. But maybe someday we'll have that for our web services. Probably not.
So if you had a system that maintained inventory and you're trying to populate your storefront, that's a services application. But you have a use case example of how that would work.
I'm not entirely sure what you're asking.
Well, the storefront, you keep inventory in the storefront. Okay. But what if there was another system that's non-Drupal? Or maybe a bunch of systems. Different vendors, for example.
Yeah.
Or what if the other vendors actually had a catalog system and you wanted to populate your Commerce Guy system from that? Yeah.
So your question, I think, really gets at the heart of where we're going with Commerce 2.x on Drupal 8, which is the idea that your website is really just a conduit of information. It's not a container. You don't do all of your e-commerce in your Drupal website. Nobody does. They all have an external analytics solution, and some have external inventory and fulfillment services that they need to integrate with. And so I don't have, off the top of my head, a great example for what this looks like. No, I do. I'm actually building a website for a friend on Pantheon, who he has been managing his entire business through Google Docs, and he has his employees at mall kiosks actually using Google Docs to put in sales and log their time and all that kind of stuff. So it's a very trusting system, and it's not ideal. It's not suited to his use case. What we're doing is creating him a website that his CSRs can actually use to manage orders and email receipts using the iPad. So he'll have one version of this website on the iPad, something else if somebody goes to it from the web browser, and we'll be communicating Well, in his case, we won't actually be using a web service, will we? We'll just actually have the browser already on the iPad. But like that's the idea. If these, if it wasn't so easy as that, making it easier for Drupal websites to consume and to serve up that data, it only serves our interests as commerce grows and expands and becomes more interconnected. And also, a really nice thing for the Drupal community is that this kind of integration work is very expensive. So if you are pitching this kind of project to an e-commerce company, you can charge them lots of money. And that's why I get to work without working for clients directly, because our other guys in the team are doing this kind of work, and it just results in big projects that take a lot of money to implement. So, I mean, in a sense, I want to make it faster and cheaper for people. But in the meantime, you can make good money doing this kind of integration work. I saw a question in the back.
Yeah, I have a question. Is there an example of someone, not necessarily in Drupal, who sort of developed a REST API that they've published as a good example?
Yeah. In fact, there are some. The question was, is there a good example of a REST API and what that might look like? And I met at RESTfest, which is a REST API development conference in Greenville, South Carolina, my new hometown. So of all places in the world, I moved to the place that has RESTfest every year. I met the architect behind the REST API for Elastic Path, which is an e-commerce system that has a full REST API. And they're using a lot of their own media types instead of any sort of standard or generic media type. But they basically have implemented and documented a full-on e-commerce REST API. And I was happy to find out that their product data model is basically the same as Commerce's. So I felt like we were developing in a good direction. But that's the best. If you want to see a simpler example, though, my link or my API example here for the Maze XML. There's a link here that actually talks through the Maze XML REST API, and also Mike Amundsen's book, Designing Hypermedia APIs with HTML5 and Node, walks through the creation of that REST API. So if you want to, you're more than welcome to come check out the book afterwards. I have a couple up here if anybody wants to look at them. This is the RESTful Web Services Cookbook, which is also really cool and helpful. But I'd look in those places. Yeah.
So as a developer, I haven't had a real need or I guess the expertise to really develop much APIs in the sites that I've built. What kind of concerns or ideas should I keep in mind as I start to moving forward? And I know this is a lot more low level than I talk, but if you have any advice.
Yeah, so the question was what concerns should you have in mind if you're setting out to build your first ever API or whatever? Is that more or less?
Yeah, some great APIs.
Yeah, I think, geez, there's so many. What I would do is I would start here. So start by thinking about your web service in terms of what are my data objects that should be exposed to my users. That may not map to your database schema. It shouldn't map to your database schema in most cases. You should really be thinking, how are people going to use and consume the information in my in my server, and then what's the best, most logical way that I can present it to them. And also you have to sort of think what's called coarse-grained instead of fine-grained. So like HTTP is designed to transmit a lot of information. It doesn't have to be like these atomic small little chunks. Send a 15 kilobyte document that has in it all the information that somebody needs to use your client if need be. But sort of think about the big picture, high level. How would somebody actually use the API to make a mobile app, or to invoke it from some other website and embed something on their website or whatever. So think in those terms. So how is the client going to use it? And then how can I define my data objects at that level so that it makes sense to them? And then how do I use the HTTP methods as verbs to manipulate my data and to manipulate my data? So where are people creating new data points in my, new records in my database, or reading them or manipulating them or whatever else? So I'd start there, and then I'd get that ebook from Apogee, which is all the best practices for basically building that API. And I think that if you start here with HTTP type 1, you're a lot better off than if you start even here, where you just have API endpoints that you're trying to program against, because it'll be easier for you to move forward from here. Everything that you do, if you start at this point, is really just extending the web service as opposed to having to rewrite it and redocument it. So you start here and then sort of move your way up the chain, and you're basically dealing with adding more information to your API over time instead of having to fundamentally change how it's been constructed. Yeah. There are a lot of other tips in the books and articles. Actually, this presentation is on GitHub, and the front page is just a bibliography of all the different resources that I use in books that I've read that have helped me learn. So, let me see if anybody else has one, and then I'll come back. Then any other questions elsewhere in the room? All right, one last one up front, and then we'll cut it off.
You didn't really talk much about authentication.
Yeah.
Like a lot of these services, anybody could just send a message to these guys, and send a post, for example.
Yeah.
Strategies for.
Yeah. So the question is, how are you doing authentication for your web service? And the typical way in Drupal right now is to just do session-based authentication, where you actually log in remotely and store the cookie, and then send the session ID in each follow-up API request, and then Drupal handles authentication and access control and all that. I'm not a huge fan of that. It's not RESTful, in the sense that it requires sort of prior information, like you're sort of retaining what's called application state locally, and so then it's a thing. I'd do it though. If I was going to do one today, I'd probably at least go with basic HTTP authentication, where you send the username and password, in your HTTP request. If you've set up a web server where you have the pop-up that says, "What's your username and password for accessing the website?" That sort of authentication would be my sort of base level, and Drupal 8 will be supporting that, as far as I understand, for the REST module. But beyond that, it's something that I don't really have a good answer for. Within Commerce Guys, we're using OAuth 2 for people that connect to our commerce marketplace from the Drupal website. So that's another option. It's a pretty popular option as well. And then I think, whatever else, kind of up to your own. REST itself isn't really concerned with how you authenticate or manage access to it. But obviously, the assumption is that you will be doing this 9 times out of 10. However, maybe you just have a Maps API where all the data is public, and you send a request to Google Maps and get back a map, and it doesn't really matter who you are when you do that. You're going to get back the same information every time. In that case, they don't care about authenticating anything. They just send you back the data and let you do with it what you want. Yeah. Are there any final? No. Let's close it out, and then I'll stick around to talk and show books and things like that afterwards. Thanks.